Guys, welcome back to LearnAPChem here at LearnAP. Today in this video we're going to go over moles, molar mass, and molarity. So basically we're going to talk about moles. So we're going to cover like what is a mole, molar mass, finding molar masses, converting between moles in chemical reactions, and molarity. As usual, be sure to leave a comment if you're confused on any of this stuff, or you can also ask in the weekly live streams we do every Sunday from 5 to 6 p.m. Eastern, where we answer your questions about AP Chemistry. Other than that, we'll get started. Alright, so let's talk about what is a mole. So when we talk about a mole in AP Chemistry, we're not talking about the animal, a spy, or a blemish on the skin. A mole in chemistry is basically just a number, 6.022 times 10 to the 23rd of something. So if I had 6.022 times 10 to the 23rd number of carbon atoms, I would have a mole of carbon. And you should definitely memorize this number, 6.022 times 10 to the 23rd, and this is called Avogadro's number. Okay, well you might be thinking, so what, 6.022 times 10 to the 23rd, who cares? How is this useful? So it's useful in the sense that we can use moles in a lot of different ways. This first way is molar mass. So when we have a mole of something, particularly atoms or compounds, we can easily determine its mass in grams using the periodic table. So this is called molar mass, and all it means is that the mass in grams of a mole of something. So if I had AgCl2, its molar mass is simply the number of grams of 6.022 times 10 to the 23rd number of AgCl2 molecules. Now to find a molar mass, all we have to do is use the periodic table. So let's do that. So here, I'm going to write down Ag's atomic mass. So Ag is over here on the periodic table, 107.87. 107.87. Now we'll look at chlorine. Move over here, and you can see it's 35.45. Now this means that for a mole of silver, it weighs 107.87 grams. Similarly, the same thing goes for chlorine. So if I wanted to find the molar mass of AgCl2, I would just do 107.87 plus 2 times 35.45. And if we work this out, this is going to come out to 178.77 grams. So that's all you have to do to find molar mass. You just find the compound, or I'm sorry, the atoms that's in the compound. So here that was silver and chlorine. Find their molar mass, and then add that all together. And then if you have, say, a subscript, you're just going to multiply it by that subscript. Alright, so let's do a quick practice problem. We have a sample of 0.67 moles of CO2. What is the mass of the sample? So I want the mass in grams. So pause your video, unpause when you think you found the answer. And I will zoom in on the periodic table for you to just sort of give you a reference. Okay, so first thing we're going to do in this problem is we're going to find CO2's molar mass. So I know that the molar mass of carbon is 12.011 grams, and oxygen is 15.999. And I would just find this on the periodic table here and here. So that's where you would go about finding that. Now we have to add this up, so we have 1 element of carbon, so just one of those, and then 2 of oxygen, so 2 times its molar mass, 15.999. This is going to get us 44.009 grams per mole. Okay, so I know that I have 0.67 grams of CO2, and that I have 44.009 grams of CO2 for 1 mole of CO2. Again, that's just what the molar mass is. So I can sort of divide this out, and I will end up getting 0.0152 moles. Now, here in our original thing, we only have 2 sig figs, so I need to round this answer 0.015 moles. Alright, so now let's talk about using moles in chemical equations. So you can use moles in chemical equations to determine how much stuff will be made. This can also be used to determine things like limiting reactants and percent composition, but we'll talk about these later. But just know that, it can also be used for other stuff. So let's look at an example. Given that we have 5 grams of chlorine, how much potassium will be made in the reaction 2 potassium chloride yields 2 potassium plus chlorine? So here, I'm going to first convert this 5 grams of KCl to moles. So first I would find the molar mass. Sort of talked about doing this earlier, but here I know that the molar mass of KCl equals 74.54. Okay, so all I have to do is say 2. Okay, so first I'm going to convert this grams to moles, grams per mole. Okay, so 5 grams KCl is equal to 1 mole over 74.54 grams. I'll make this clear. 1 mole KCl. And then I know that if I have 2 moles of KCl, I have 2 moles of potassium. And how I'm getting that basically is I'm seeing that there's 2 here and 2 here. So that's all I'm doing. And then all I have to do is sort of multiply this through. So 5 over 74.54 times what's basically 1, 0.06707 moles of K. Now if I go back up to the problem, I'm asking how much K will be made in the reaction. So I'll assume that I want this in grams. So I need to know the molar mass of K. Which is 39.09. And then I just want to convert moles to grams. So 0.06707 moles of K over 1 times 1 mole of K being equal to 39.09 grams of K. And so all I do is multiply 0.06707 by 39.09. I get 2.622 grams of K. And then again, I'm going to go up here. I see that I have 1 sig fig here, so I need to round this to 1. So this just becomes 3 grams. Okay. And you can see that although we have the same number here, we have 5 grams going into the reaction, but we're only coming out with 3 grams of potassium. So that's a good way to use molar mass, is to sort of convert between weights of the products and the reactants, or different products versus a different product. And then again, right now, we're assuming that this has 100% yield. I'll talk about that more later, but just sort of be familiar with how to do this. Alright, finally, let's talk about molarity. Now, molarity is a quantity used to describe the concentration of a solution. So, it's abbreviated with a capital M. So if I have a 5 capital M solution of X, this means that I have 5 moles of X per 1 liter of solution. So that's all molarity is. It's describing concentration. If I have a higher molarity, that means I have more moles per liter of solution, therefore higher concentration. Now let's look at how we would use this. How many moles of HCl are in 11.3 liters of a 3.76 m solution of HCl? So we would start by saying that we have 3.76 moles of HCl per 1 liter. This is all molarity is, as I described up here. Now, I just need to multiply through by 11.3 liters, and this is going to give me the amount of moles. So 3.76 times 11.3 leads me to 42.488 moles HCl. Around the sig figs, we get 48.5 moles of HCl in 11.3 liters of a 3.76 m solution. Alright, so that brings me to today's challenge problem. Determine the number of moles of H2O needed to decompose to make 100 grams of oxygen. Assume that there's a 100% yield, so this is a perfect reaction. All of the water in this reaction is being broken down. The solution to this is on our website, LearnAPChem, and I'll also include a direct link in the description. If you found this video helpful, please like and be sure to subscribe for future content. Like us on Facebook and follow us on Twitter for updates about our new videos and live streams, which we do every Sunday from 5 to 6 p.m. Eastern, where we answer your questions about AP Chem. Links for that stuff will also be in the description. Leave a comment if you're still confused on any of this stuff, or also any other comments on the video in general. Other than that, I want to thank you guys for watching, and I'll see you in the next video.